As I was saying that when you've been given the principal number to be 3, then you've been given azimuthal to be 2. Then that 2 you are going to use to identify the block, which is this D block. We called them the other side. This side we called them what? We call them the orbital. For you to identify it, you have to calculate for the azimuthal. And when you've gotten the azimuthal, you will come to the table, and coming to the table, you will find that it is D. And the maximum numbers of electron in D is 10. I hope that is clear. Is this 10? And for you to write it, now you will use this energy of principle 3D. You will not write 2D. You will use this one here for principle to write it. So 3D is equal to 10 electrons. That is clear. Another one, note below, that if you have been given three quantum numbers, the maximum number of electron is always 2. Another thing that you should note down, let me explain this. When you've been given the three quantum numbers, for example, you've been given the principal here, you've been given azimuthal, then you've been given the magnetic here. Hizi tatu pekee ndio umepewa, hujapewa spin hii ya chini, umepewa hizi. The maximum number of electron is what? 2. I hope that is clear. Another thing that you should note down is that whenever you have given 4 quantum numbers, now it has exceeded, now it is 4, umepewa hizi zote. The maximum number of electron there is what? Is 1. That is as per the question here. Calculate the maximum number of electrons, and the questions are these ones here. So I hope that is clear. Then I hope in quantum numbers we have another one called magnetic quantum number. We never we never show its meaning. Magnetic quantum number always shows orientation of electrons in the space. Like for example, when you look at this one here, these are the electron numbers. These ones here are the electron numbers. The way they have been oriented, that is the function of this magnetic quantum number. Then we have spin, which was the last one. Spin shows the state of an electron. Spin always shows the state of an electron. How? When the electron has been spinned upwards, it will be positive a half, and when it has been spinned downward, is the magnetic the spin quantum number is going to be negative a half. I hope that is clear. So lastly, I want to go through these ones so that other things we'll do in the another class. Another question here comes like, determine whether each set of quantum numbers is allowed. For example, this Roman 1, we've been given n to be 1, l to be 1, and ml to be 1, as ms to be a half. Here it is not allowed. Why? Because when n is 1, l should be n minus 1, and when we take 1 minus 1, here should be 0 but not 1, and that is why it has not been allowed. Hope that is clear. The second one, we have n is equal to 2. When n is equal to 2, l should be n minus 1, and n is 2. 2 minus 1 should give us 1, and when you check at this, l is equal to 3, and that is why it is not allowed. It is not allowed, and it is not allowed. Another one another one, as the correct one should be this one here. When you check this one, this is the correct one, but not this one. Another one, we have n is equal to 3, l is equal to 2, that is correct. ml is equal to -1. -1 not allowed. Why? Because we say that magnetic quantum number relies on the azimuthal quantum number, and when you check at the azimuthal quantum number, it begins with +2, and when it was +2, when you want to note down this orientation, the orientation of electrons in this magnetic quantum number, it should be -2, -1, 0, 1, and 2. So when you check here, -1 is there, and that is correct. Then ms, which is the spin, I said that spin is constant, whereby it has only a half, positive half, and negative a half, these ones. But when you see this, it is not existing. This one is wrong, and that is why it does not satisfy the set of quantum number. Hope, be blessed, go through the work until we meet again to the next class. Thank you, my good people.